Today, everyone, we are going to continue our conversation about graphing and a discussion on parent functions and things that we can do to manipulate and change them. Today, we're going to be talking about stretches and flips. Okay? And I'm going to give you a couple examples of both and how we can take a parent function that looks like this and turn it into something that looks like that. Okay? So eventually we're going to be talking about a handful of other things. We're going to be moving it left to right, moving it up and down. So there are 4 different types of transformations that we can do. Today we're just talking about stretches and flips. Tomorrow and the day following we'll be talking about the other 2. Moving it left to right, moving it up and down. So today, stretches and flips. The reason that both of these are being talked about together is in most equations, they happen in the same place. So if I have an x squared, and we talked about this yesterday, if you graph an x squared, it's going to look like that. And I throw something in front of that x squared. I multiply the x squared by something. So let's say I multiply it by 3. So it now becomes 3x squared. It's going to get skinnier and shoot up a lot faster, which makes sense because everything that we plug in for x, after we square it, is also going to get multiplied by 3. So it should go up faster. And then if I do something like a negative x squared, then instead of going up, everything's going to go down. So I'm going to look exactly like x squared, but instead it'll be negative. And then the last transformation would be like if I have a 1/2 x squared. That means after we square it, everything will get smaller, so it will take longer to go up, so it will get kind of fatter and wider. And I'll give you the math for all of these right now. Okay, so I'm going to do 3 examples. Before I give you any of the examples, let's make our table for x squared. Okay? So looking at x squared, so y equals x squared. Let me make sure you can see this okay. Yeah, you're okay. Y equals x squared. So x equals y equals, we do -2, -1, 0, 1, 2. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So there's our table, 4, 1, 0, 1, 4. So those are all of our points. And it's going to look something like that. Okay? Then we're going to let's look at y equals 4x squared. We have our x values, we have our y values, same values for x. -2 squared is 4. Times 4 is 16. -1 squared is 1, times 4 is 4. 0 will still be a 0, 0 squared is 0. 0 times 4 is still 0. 1 squared, 16. There we go. Notice that all of the values over here got multiplied by 4. Which makes sense, because we multiplied the whole thing by 4. So at -2, instead of at 4, we're at 16. So if this was the point -2, 4, and this is the point -1, 1, and here's 0, 0, 1, 1, and 2, 4. Now all of a sudden, my -2 is up way up here at 16. So it's going to be much skinnier and go up much faster. So it's going to be skinnier and go up faster. Okay? Let's do, I'll read as much of this as possible. Look at, instead of a 4x squared, let's look at a -2x squared. A reminder, remember your premise, your order of operations. You're going to do your exponent before you do your multiplication. So -2 squared is 4, times -2 is -8. -1 squared is 1, times -2 is -2. 0 will still be 0. 1 will be -2, -8. Okay? So notice, we're still going faster because the absolute values are larger, like 8 is bigger than 4. But it's going to be going down. So it's going to be going down and it's going to be going faster. So now our graph is going to look like that. All right? It's going to look a little bit different. And then the last one that I want to demonstrate is that fraction. Anything between -1 and 1, except for 0, which just gives you a straight line. So let's do like negative, let's do -1/2, it's easy math, x squared. Okay? -2 squared is 4. 4 times -1/2 is -2. -1 squared is 1 times -1/2 is -1/2. 0 is 0. And my 1s and my 2s are the same for x squared. Okay? So now all of a sudden, all of these values have again been flipped, so I'm going to be going down, but it's going to take me much longer to get there because the values are so much smaller. So it's going to be a little bit wider. Okay? So those are stretches and flips and how they affect what the graph ends up looking like. So real quick, for all of our values, x squared, these are all of the equations that we talked about yesterday. Okay, for x squared, the stretches and flips happen right there. For x cubed, stretches and flips will happen right there. For the absolute value of x, if it's a stretch, it will happen right here or right here. It can actually happen in either place. But for it to be a flip, it has to happen on the outside because a flip won't affect anything on the inside. Okay? So that's how that works. Square root of x is kind of the same deal. Stretches and flips, but you can only flip it outside. And then what's the last one that we talked about? Oh, just x. X will always happen. Okay? So be aware of these. If you're going to do a flip, you have to put the negative outside the absolute value or outside the square root of x. Okay? What you're going to look at today are a handful of equations. We're going to start with the standard equation, and then I'll be giving you the new equation on how it's stretched and flipped, and be asking you to fill out the chart for both of those. So pretty much exactly what I just did up here on the board. Okay? So go ahead and get to work on that, and I